Hello friends. In this session we are going to look at one of the important concurrency utility in Java, which is cyclic barrier. In previous video we have seen CountDownLatch, and we will start by comparing cyclic barrier with CountDownLatch first. So on the left hand side you see in the CountDownLatch there is one thread which waits for 3 other threads to complete. So here the main thread is calling await method, and it waits for all the 3 services to complete its operation. So when first thread completes its operation, it would call countdown, second thread would call countdown, and when third thread calls the countdown, then only main thread would continue. So as you can see here, the main thread is waiting for all these 3 services to complete its action. And this countdown latch is not reusable, you can only use it once. Now let's look at cyclic barrier. In cyclic barrier, multiple threads are awaiting for each other to complete. So each thread would call await. So here you see the main thread calls await and other threads called countdown. Here each thread would wait, and they would wait until others are completed. So when last thread calls await method, then the barrier is reached, and after that each thread would continue. Now unlike countdown latch, cyclic barrier is reusable. That is the reason there is a cyclic word in it. So each thread can call await method again, and this process can repeat. So this kind of thing is useful when multiple thread wants to work in phases, and they only want to continue when other threads are completed their action. So what is cyclic barrier? So cyclic barrier is a synchronization aid that allows set of threads to wait for each other to reach a common barrier point. The barrier is called cyclic because it can be reused after the waiting threads are released. So this can be reused unlike countdown latch. The await methods until block last thread in a party arrives. So await blocks each thread until last thread arrives. Now let's jump into the code and see cyclic barrier in action. Now let's look at one code example for cyclic barrier. I will create a class cyclic barrier. Now in this class, let's add one main method. Now I will also create few worker threads for showing the cyclic barrier examples. So let's create one class that implements that part. So I have created this worker thread class now. I will override the run method. Now in order to show cyclic barrier usage, we need to pass cyclic barrier object to this thread class. So let's create a constructor. Along with cyclic barrier, I will also pass a task name so that we can identify different threads while demonstrating the example. Now let's create private variables for the same. And now assign these values to local instance variable. Now we need to also create a utility method random wait. In this I will only do thread.sleep and wait for random time by using math.random method. Let's surround this with try and catch block. Now we are going to use this random wait to simulate thread doing some work. As we discussed, like cyclic barrier is used in phases, so we will simulate few phases here. Say this thread is completing phase 1 first, so we will print phase 1 started, then some random wait to show that phase 1 is getting done, and once it is done we will print phase 1 completed. Now we want each thread to await at this place for other threads, so I will call cyclic barrier.await here. Let's add try and catch block. I will move this try outside, and also will collapse all the catch blocks here. Now we will repeat same thing for phase 2. I will simply copy paste and put it phase 2. Since cyclic barrier is reusable, you can see here I can call CyclicBarrier.await again. Once phase 2 is complete, all the threads would go for the phase 3. Now let's create cyclic barrier object that we need to pass to these threads. Now I'm going to create a 3 threads, so I will pass 3 as a argument to cyclic barrier. Now let's create a for loop and iterate it for 3 times, and then we will create a 3 threads. We'll call new thread and we'll pass worker thread object. Now we will give some task name for each thread, say task plus I, so that we will have 3 tasks, task 1, task 2, task 3, and we'll pass the cyclic barrier object. On this we will call the start. Now cyclic barrier provides another method that we can pass to its constructor, which is barrier action. Now this barrier action is invoked when barrier is reached. So I am going to print barrier is reached, so that we understand that a barrier, every time barrier is reached, we can see the barrier is reached printed. Now let's go and run this example. If you see here, the phase 1 is started, and as soon as phase 1 is completed, the barrier is reached and phase 2 is started. The same for the phase 3. So you can see clearly here that for each task phase 1 is started, then phase 1 is completed, and as soon as all the 3 threads completes their phase 1, barrier is reached, and only then each thread started with phase 2, not before that. Same thing happens in a phase 2 as well. So phase 2 we started with the phase 2, all threads, and when all the threads completed the phase 2, then barrier is reached and then the phase 3 started. So this is very useful in the scenario where you want all the threads to coordinate on each barrier. You want the threads to complete particular action, then wait for other threads to complete it, and then move to the next action. Then again wait for that action to be completed until they move to the next action. So that is where the barrier is very useful. So this was a code example for it. I hope you enjoyed this video.